Honors Chemistry, we are starting a new unit. The unit is called Reactions, and this is the first lesson in that unit. It's lesson 9, and it's on compound names. It's a very short lesson. So ionic compounds consist of a cation, a metal, and an anion, a nonmetal. When naming ionic compounds, the cation is named first and it retains its original name. The anion is named last and the end of the anion's name is changed to "ide." So with ionic compounds, there's only two compounds involved: a positively charged cation, a negatively charged anion. So here are some examples. So if the metal is sodium and the nonmetal is chlorine, then sodium ionizes to become a +1 charge, loses 1 electron to be like its nearest noble gas. The chlorine gains 1 electron to become like its nearest noble gas. Again, you can see these on the periodic table. And then the sodium, the sodium, the cation retains its name, sodium, but the anion changes the last part of its name to "ide," so from chlorine to chloride. So the compound is NaCl, and the name is sodium chloride. Potassium and fluorine. Potassium becomes a +1 charged cation. Fluorine becomes a 1- charged anion. Fluorine changes its name to fluoride. The compound is Kf, and the name is potassium fluoride. Magnesium is the metal. The nonmetal in this case is oxygen. So magnesium retains its name, magnesium. Oxygen is changed to oxide. The formula for that is MgO, +2 cation and a 2- anion in oxygen. And that becomes magnesium oxide. And one more, lithium. The nonmetal being sulfur. The cation is lithium, keeps the same name. The anion is sulfide. The compound is Li2S. And the name is lithium sulfide. So that's very simply how you name ionic bonds that involve the group 1 and 2 elements. Those are the alkali and alkaline earth metals in the first 2 columns, as well as any of the nonmetals. Some transition metals have more than one charge state, and you have the periodic table of ion charges. I think it's called ion charges by number, charged ions by number, something to that effect. And you also have the 60 common ion sheet. So that's where you find the charge states for transition metals. You're not expected to have those all memorized, or any of them memorized. So for example, iron Fe can be ionized to a 2+ or 3+ charge, meaning that the atom loses either 2 or 3 electrons. When naming an ion with more than one charge state, a Roman numeral is used in the name. So I is the number 1, Roman numeral 2, II is the number 2, Roman numeral III is the number 3, Roman numeral IV is the number 4, and Roman numeral V is the number 5. The way Roman numerals work is if you put a letter that represents a smaller number before one that represents a bigger number, such as IV would be 1, 5, where 4 is, you subtract the I. It's kind of a strange notation. You don't really have to know it for this class except to this extent. So examples. So a metal of iron. Now we have to determine which charge it's going to be. Is it going to be a 2+ or a 3+? And the nonmetal is oxygen. So we're going to say it's iron 2. It's a 2+ charge. It lost 2 electrons. The anion would be oxide. So the compound would be FeO. So when you write it as a compound, like in a chemical formula, you would just simply write FeO because it's a 2+ and oxygen is a 2-, so they match up perfectly. So it's 1 Fe for 1 O, 2+, 2-. But the way you would write the name out is iron 2 oxide, and that's the way you would say it, iron 2 oxide. Copper, fluorine, Now we're going to use copper 2. Copper has 2 charges as well. We're going to use copper 2 in this case. The fluorine becomes fluoride. It's CuF2, and it's copper 2 fluoride. Titanium, chlorine. Okay, we're going to use titanium 4. So titanium has several charges. We're going to use the 4+. That means it's lost 4 electrons to be a 4+ ion. Chlorine becomes chloride. It's TiCl4. Again, if you don't understand why the 4 is there, go back and review the last lesson where we talked about the crossing arrows method to determine the subscripts on the compounds for ionic compounds. So the chlorine has a 1-, titanium has a 4+, so you need 4 of the 1- to match up with the 4+. 4+, 4-. And that would be titanium 4 chloride. Cobalt, bromine. We're going to use cobalt 2 in this case. Bromide, and cobalt Br2. And so that's cobalt 2 bromide. Now we'll deal with covalent compounds. Covalent compounds consist of 2 nonmetals. It's what we studied in the last lesson. Covalent compounds use prefixes. Those are words attached to the front of a word to indicate the number of atoms. The prefixes, and you should memorize these, particularly the first, I would say 6. The last 4 we don't use quite that often. But there they are. So the number 1 is mono. The number 2 is di. Sometimes a 2 can be represented by the prefix bi, B-I, like bicycle. But in this case it's di. 3 is tri. 4 is tetra. 5 is penta. 6 is hexa. Beyond this, we really don't use these that much, but just learn them anyway. 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. The rules for naming covalent compounds are: 1. The least electronegative atom, which is usually the central atom, is listed first. 2. Use the proper prefix in front of the element. Exception: do not place mono in front of the first element's name. 3. Add the suffix after the word IDE to the end of the last atom. Note, unlike ionic bonds, which consist of 2 atoms and are charge balanced, covalent bonds can consist of many atoms and can produce ions. So let's look at some examples. H2O is dihydrogen because there's 2 hydrogens, monoxide. Take off the O on mono when applied to oxide, so it's not monooxide, it's monoxide. Again, it's virtually never called this, but this is the technical official name for water. CO2, carbon dioxide, because there's 2 oxygens. Not monocarbon dioxide. You don't put mono on the front of the name of the first element. SO3, sulfur trioxide, not monosulfur trioxide. N2O4, dinitrogen, there's 2 nitrogens, tetraoxide, but it's take off the A and it becomes tetroxide. Dinitrogen, 2 nitrogens, tetroxide, 4 oxygens. Take the A off of the tetra when applied to oxide. CCl4 is carbon tetrachloride. And finally, IF7 is iodine heptafluoride. And that's it for naming. It's just that simple. This will not be on your test, your unit, your first progress report test. And but this assignment is really due a week from today. Focus on studying for your test, and then do this after Wednesday when you're done, or after you're done with your test on Wednesday or Thursday. Okay, and that takes care of that. Have a good day.